Thank you for kind introduction. Today's my talk is about networked high-speed vision system. Especially, I explain how to synchronize the frame acquisition in the networked high-speed vision system. This is the outline. First of all, I introduce the motivation of this work. I will introduce some previous works performed by our group, and I will explain what is the goal of this work, and I will explain what the major challenge is in this work. And next, I will show the experiments, and finally, I will make a conclusion. At the beginning, I would like to show you some videos of our previous work. It doesn't work. Ah, yeah, okay. Okay, I can do it myself. I can do it myself. Okay. Yes, thank you very much. It works. Sorry for waiting. These two robots play baseball. The near side robot throws a ball, and the other one hits the ball. In this system, two cameras swung mechanically, and it tracks thrown ball. And the ball position information is feedback to control the batter robot. And I'd like to show you another video. So the camera frame rate is 1,000 frames per second, and using such a high frame rate camera, we can use the visual information to control such kind of very fast robot. So the high-speed vision system is very powerful to control such a real-time, very fast feedback control system. And I'd like to show you another video.
This system can transform items around us into computers.
It is not only for the
now, a woman is seated in front of a large device.
Useful for human
what will she experience? You can treat a paper as a smartphone, and rapid paper movements present no problem.
Onto this piece of paper,
of course, a movie can also be played on it.
Is,
not only images, you can also experience tactile sensations. Tactile sensations are felt on a selected number, and tactile sensations can change position when the number's location changes. Our hands become a numeric keypad. We can perceive the selected number from both visual and tactile sensations if our hands move. Then we can experience fireworks shining on our hands with the sense of touch while moving our hands. This system embeds information into existing environments and objects. It points the way towards future dynamic changes in our information environment.
in these previous works, only one or few cameras are used. So such a system is suitable for motion in only limited area, but it's not suitable to objects move along much more wider range. So the goal of this work is develop a networked high-speed vision system. In the system, a lot of cameras are connected via network, like Ethernet, and object moving across much more wider range can be seamlessly tracked by the networked high-speed vision system. This is our goal of this project. And the major challenge in this work is frame synchronization. In ordinary 30 FPS vision system, only few millisecond synchronization error is acceptable, but it can be fatal in 1000 FPS class high-speed vision system. So the frame synchronization is very important problem in this work. So I propose a scheme to synchronize the frame acquisition between among the cameras over the network. I explained the scheme, and suppose that only one master camera and only one slave camera exists in the system. First of all, the clocks of master and slave is accurately synchronized. And when master camera triggers the frame acquisition, the timestamp is acquired. And the timestamp T1 and frame interval delta T is sent to slave. And the master and slave would keep watching the clock and wait for the next timing of trigger. And at T1 plus delta T, master and slave trigger the next frame acquisition. The frame acquisition trigger is accurately synchronized. And repeating the same procedure, the synchronized frame acquisition can be achieved. In this scheme, we use Precision Time Protocol, PTP. It is standardized as IEEE 1588. This protocol provides very accurate timing clock synchronization with only microsecond order synchronization error. Other candidates is NPT or GPS, but NPT accuracy is millisecond order, and it is not acceptable in our high-speed vision system. And using GPS is allowed only in outdoor environment. Therefore, we use PTP. And now I would like to move on to our experiment. In the experiment, two PCs are used, and the PCs are connected via Ethernet, and cameras are controlled by each PC. And the smashed ping pong ball is tracked by two cameras. And the camera control signal is observed by oscilloscope. And this is the measured camera control signal. The two lines indicate the two cameras shutter controlling signal. And the result shows that the two camera control signal is accurately synchronized with only small error around less than 10 microseconds. And this is the tracking result. The ball position X and Y calculated in every frame is plotted. And the ping pong ball bounced here, and this shows the magnified view around the bounce. the result shows that the two positions acquired by two cameras are accurately synchronized, and the bounce observed at the same timing in both cameras. Thus, the developed system works well. And in our system, the frame interval was 2 milliseconds, and the network delay is around 1/10 millisecond. And if we use much more larger network or more highly loaded network, the network delay can be more significant. And time sync error by PTP is less than 1,000th of millisecond. So the proposed scheme is effective to avoid effect of such a significant network delay. Now I conclude my presentation. I propose a frame synchronization scheme for the high-speed vision system. And frame synchronization is very important in network high-speed vision system. The frame synchronization performance of the proposed scheme does not depend on the network delay. This is very important feature of the proposed system. Thank you for your attention.